All right, so let's get started. I have everything set up right now perfectly, and I'm gonna attempt to record again, but this time upload it as a Zoom link rather than a YouTube link. So hopefully that comes out really well. But the slides have already been posted on Canvas for you guys to access just in case something happens. But yeah, there's a lot of things that we're going to cover today so that we can make room for what we're going to cover next week, because I think the concepts that we're going to cover next week are, I'm not going to say they're more important than this, but they do require a little bit more time and attention. Okay, so a little bit of overview of today. We're going to first do a quick review of last week's material. Last week, we discussed dictionaries and list comprehensions. And so we'll do a quick review of that. We'll also cover Thursday's lecture material completely. And so that includes the Python map function, the Python zip function, functions with files, and just simply file IO. And then the Monday lecture material will cover just collections. So from today's lecture that you guys attended, hopefully, we'll just cover collections. And I believe he may have started NumPy today as well. We'll do NumPy next week because I feel like, again, like I mentioned previously, that NumPy requires a little bit more attention. And since it's since it's a very important concept, I do want to dedicate a whole recitation to just NumPy. Okay, and so we'll start NumPy next week. But we have the 4 or 5 main concepts here, and we'll cover that today. Here's the GroupMe link. You guys can just access it on files, but if you guys want to take a picture of that, go ahead. That's in case if you don't want to email me or quickly want to just reach out to me on GroupMe. I'll try to respond as fast as possible using the group chat here. So I have that there for y'all. If you, and I'm just going to quickly go through this, but it's on files on Canvas if you actually need the link. Okay, so let's first review dictionaries. And so if you guys remember, with dictionaries are simply just collections of key value pairs where keys are unique and can be used to access the corresponding value. Recall that with lists and tuples, we access the elements with numerical values. And so when we access, let's say, the 5th element of a list, we'll put 4 in the brackets, the square brackets. But in dictionaries, it's a little bit more different. We have a key and a value. The key can be a string value, and with that string value, we can access it. Think of again like a dictionary. When you're reading a dictionary, you're finding a word in the dictionary, what are you using as your way of finding the word? You're not using the page number because you don't know the page number of that word in the dictionary and to find the meaning of that word. What you do is you try to go, let's say if you're finding the word hello, you'll go to the H section and find the word hello there, and then you find the meaning there. In this case, meaning would be the key, and then, meaning would be the value, and key would be the word itself. Okay, this is the basic syntax of dictionaries. We're going to be using square brackets for dictionaries. You can make dictionaries multitude of ways. I have 3 very basic ways. One is an empty dictionary, one is a dictionary from keys, and so you'll have these keys, and then a dictionary from a tuple, a list of tuples, and that list of tuples has a key and a value. And so with dictionary 3, you would use key 1 in the brackets and key 2 in the brackets to access value 1 and value 2 respectively. Okay, I have an example there as well, and the things that you can use to access the elements or change the elements of a dictionary. So you can access the element with let's assume that the dictionary goes by the letter D. That's the name of the dictionary. You can use square brackets with K to get the element of the dictionary, but the issue is that what happens when there isn't anything there? Well, it will shoot an error. And so in that case, we can use the d.get k in parentheses, and that accesses the value associated with k. And in case that value doesn't exist, there won't be an error and it won't terminate the program. If you want to see the items of a list, it will you can use d.items and then the method there, and that returns the key with the value and a list of tuples. When you want to just access the keys, this is super important, by the way, because you're likely going to use this in a for loop. And so to access all the keys, and you want to iterate through a dictionary, for example, with the keys, you need to find a list of keys that you can iterate through. And so d.keys in parentheses, or the method for that, would return all the list of keys. If you want the values, which is a bit strange, but you may need it for something, you can use d.values method and it will return a list of all the values in the dictionary without the keys. Okay. Now, let's say if you want to add D2 elements to into a new into an old dictionary D, it'll just add the elements of D2 into D. However, let's say if D already has something or already has a key that D2 has, In that case, the D2 one will have higher precedences because you're using D2 to update the values of D. And so whatever there is in D and D2 will get the higher precedence. And so that will be added to D, okay? So that's a review of dictionaries, super important concept, and you're gonna likely be using it a lot in your future assignments. List comprehension. So list comprehension is just a concise and efficient way of creating a new list based on an existing list in Python. And so with the example I showed you previously, when I was creating a new list of, let's say, a bunch of 0 values, the issue was that I was writing it in 4 lines of code. I was first writing an empty list, and then I was creating a for loop, and then within that for loop, I was appending a 0 to that list, and then I was printing that list. List comprehensions, reduce that all to 1 line, and the benefits of list comprehensions include conciseness, readability, and efficiency. And so that's pretty awesome. The basic syntax of a simple list comprehension is as follows: expression for item in iterable if condition. What the hell did I just say? Well, expression is the thing that you're adding to the new list that you're creating. For item in iterable is simply just a for loop. So for item, big item as the thing within that iterable object. Iterable is just a list, tuple, dictionary, something that you can iterate through. And so that you can put that there, and not really required, but if condition as well, in case you want to, not put every single value within it. You have to have, if you want to have a condition. And so I give an example, I for I in range 10, if I modulus 2 is equal to 0. Basically, it is going to iterate through 0 to 9, because 10 is not included in range. And if you mod the I value from that with 2 and you get 0, it's an even number, then I want that I value to be added to the list. And so when I print that entire list comprehension is the thing in square brackets here, it'll output this new list because I asked it to print it out. Okay. You can also do nested, I don't know why I put next, but you can also do nested list comprehension. And so that's just simply an expression for item in iterable. So that is the initial for loop. Then the nested for loop is the for loop after that. So for item 2 in iterable 2, and then if condition after that. So think of it again just like your nested for loops, but in this case you're doing it all in 1 line within a listed nested nested list comprehension. I don't know why I put next there. It's kind of throwing me off. So in an example like this, we have one list with 1 through 3. We have list 2 with A, B, C. And so what I'm doing here is creating all the possible tuple combinations. And so what am I doing? I want an X and a Y tuple to be added to the list. What are those X and Y tuples? So we'll do for X in list 1. That is our outer for loop. And that is iterating through 1, 2, 3. Now this is the inner for loop. For Y in list 2. That is the inner for loop. And that is iterating through the ABC, the list 2. And so what is happening? Well, we're going to first run this for loop once, and then we'll run this for loop 3 times. And so what's happening? 1A, 1B, 1C, done. Now let's go on to the second iteration of the first for loop. 2, 2A, 2B, 2C. Awesome. We just did this this inner for loop for the 6th time, but we finished this for loop for the 2nd time. Now we got to do the last one, number 3, 3A, 3B, 3C. And so that iterates another 3 times. The inner for loop iterates another 3 times, and then that was the final iteration of the first for loop. And so we get this sort of combination of tuples. Okay. And if you're getting a little bit, if you want to do a couple practice problems, look at my previous recitation slides, recitation 02 slides. Those were the couple of practice problems. It gets harder as it goes. So if you guys want some really good practice with list comprehensions, I put those practice problems there as well. Okay, so that wraps up the review of the material that we had last week. Now let's get on to the newer material, right? Because that's what we're here for. So the Python map function, this is a very interesting function. So basically, the map function of Python applies a given function to all the elements of something that you want to iterate through. So when I say iterable, when I say iterable object, when I say iterator, I'm basically saying the same thing. Something that you can iterate through. List, tuple, dictionary, things that you can iterate through. So a collection of items, one can say. And so we can, let's say if you want to apply a function to all the elements within that iterable object, within that list, for example. And so we can do that with the map function. So with the map function, we can say, hey, map, and then as you guys know with the method, you put in within parentheses the arguments. The first argument will be the function that you want to apply to all the elements in the list. And then the second thing will be the actual collection of items itself. So list tuple. So the name of the list, the name of the tuple, the name of whatever you're iterating through will be going here. And then the function that you want to apply to every single element within that, you will put in the first parameter. Okay, so here's an example where I'm trying to find the length of every single name within this list of names. And so what I'm doing here is that I'm applying the map function. I'm putting what function I want to put. So what is this length function? Well, the length function is going to find the length of the string every time it's being passed. Now, what is that thing that's being passed? Well, it's being passed all the elements of name. So it'll apply length here, length here, length here, length here, and length here. And so once we do that, we have a map object. And so let's convert that into a list. It'll convert that into a list. And then when we print it out, we will get the elements, the length of, let's say, my name, the length of my buddy Umar, Abul, Salman, and Samir. Notice here, 6 letters, 4 letters, 4 letters, 6 letters, 6 letters. Okay, so this is not exclusive, by the way, to the length function. It can be applied to other functions. You can even create your own functions and apply that to there. And so I'll give you an example. You guys know what lambda is, by the way? Do you guys know how to use lambda? I know it's a very strange thing to use. So I'll give you guys a quick review of what lambda is. So lambda is something like, let's say you're creating a very small method for a very small purpose. So lambda would be very efficient because it doesn't necessarily need you to make a new method. Like, you know how you create a new method, like, let's put it here. Let's say def double. And so how do you double something? Well, you double something by multiplying it by 2. Okay, so we basically created a method like this that doubles the value that we're given. So if someone passes a value 5, it'll return 10. But we've created a method, and it's a very simple method. And so what lambda does is that you can do that all in like one line within it. So let's say if I wanted to create a function like this with lambda, it'll be lambda. Oh, let me separate this so that you guys don't get that confused. It'll be lambda x. X will be our parameter. And then we're going to just return 2 times x. Simple as that. So this and this are equivalent. These two things are equivalent. Okay, we're taking a parameter x and we're returning the value 2 times x. And that's why lambda is so chill, because now we've basically eliminated a method with 2 lines, and we've reduced it to a function with 1 line. I don't know why I'm writing that down, but take it as you wish. Okay. Now the cool thing with lambda is that you can apply it within the math function as well. Where it says len, you can create your own function and then apply it within len. And so that's what we'll do, for example, for the first problem. Okay. So here it says, given given a list of numbers, use map to multiply each element by 2 and return the result as a list. Okay, so we'll apply that what we learned here. So I've already done this part. I actually completely forgot that, so I was like, I knew I got somewhere. But anyway, my point is that we've already done the function, and so let's apply that to the map function. Let me erase this and let's actually create that. All right. So it says here, given a list of numbers. So we are given a list of numbers. Use map to multiply each element by 2 and return the result as a list. Okay, so one thing it's assuming is that we have a list of numbers. So I'm gonna just look and jump ahead and see what the test case that we'll be using here. It'll be numbers 1 through 5. Okay, we'll set that as our initial array, our initial list. So we have numbers is equal to 1, 2, 3, 4, and 5. Okay, the next thing to do is actually create a result array, and that result array is going to contain the list of numbers that we have multiplied by 2. Okay, so let's do that. So we'll store the result here. Awesome. So that's where we're going to store our result. Now comes the tricky part and what we're actually going to be doing in this problem. We're going to be using the map function as it tells us. So let's create the map function. Let's apply that here. Now, what's the first parameter of the map function? The math of the map method. Yeah, so that's where we're going to be storing the function. And in this case, we're going to be using lambda, like you said. So we'll do lambda. It'll take in a parameter x, and it'll multiply it by 2. That's awesome. So now we have the function done. Now, what comes the second parameter? What is the second parameter of the map function? Yeah, it's the thing that we're iterating through. What are we iterating through? A list of numbers. And so we'll put that, and since we have a name or a variable for that, we'll put numbers here. Awesome. And so what does this release? Well, this releases, a map function, not a map function, a map object. And so we don't really want to print out a map object because if you guys are taking something like CompArc, or if you take an issue to CS, if you print out, let's say like an object, like with without the toString method, it like prints where like that object is located, not the actual object itself. And so you want to convert that object address into something that's actually usable. In this case, it's very easy. We'll just convert that into a list. I believe the list function is list. I'm converting list to something else. So we'll put list in here, and we'll put list in here, and then we'll print out result. And so hopefully the result will simply be 2, 4, 6, 8, and 10. And that's how you use the map function to double all the values within a list. Pretty simple. And we're not using or creating a new method altogether. We're using the lambda function as well within the map function. Awesome. So that's one way to do it. Oh, that's one way to do it. So it should be exactly here. Yeah, awesome. Have you guys, do you guys know how to uppercase a word? Yeah, there's a function. Yeah. I just mean it with the function. So we'll do this example as well. So given a list of strings, use map to convert each string to uppercase. Let me erase all this and we'll that. Okay, so our array, let's name it R or something. We'll say hello. How are you? All right, so that is our array. And now we have to convert all the strings within this array to an uppercase letter. So let's do that. Let's create a result list. Okay. As you know, we're going to convert the map object into a list. So we'll put list first. We'll then use the map function. And then within the map function, we're going to put a function within that. The first parameter of the map function is a function. And so we'll use lambda again. It'll take in x. What is x? Well, x is going to be every word in this iterable object. And so it will take in hello. What do we want to do to hello? Well, the question tells us that we want the string to be uppercase. And so we'll do x dot upper. And so we'll return that. And then we need the list that it's iterating through. And so we name that RE. And then we'll close the parentheses. So we have two parentheses. And then when we print out result, it'll be, well, since it's a list, it'll print out hello. How are you? Okay. So that's how you would solve this problem. Yeah. Okay, so let me show you guys the answers to this one. Okay, so same thing, I just use a different array. And as you can see, we have the lambda function there as well. I'm not saying that lambda is the only thing that you can use. It's a lot more efficient. You're doing it within one line. You don't have to, create another method altogether and do that. But if that is your, something that you're chill with, something that's a little bit more easier, you can create your own method with the def keyword and apply that there. I do not have the conversion of Fahrenheit to Celsius off the top of my head, but that question is there if you guys want to tackle that. I'm going to move on from from this, and I'm going to move to the Python zip function. Okay. So the Python zip function is simply a function that is used to create a zip object. Well, what is a zip object? Well, what we're doing is that with the zip object, you can take in a bunch of parameters. It isn't that like the first parameter is a function, the second parameter is the thing you're iterating through. All the parameters within the zip object are something that you can iterate through. And so the order only matters in which you want the result array to actually give. But if you do not care about the order, then it doesn't matter the order. But yeah, so basically what it's doing is it'll combine the first element of the first iterating object. Let's first assume that we're only dealing with lists. So let me put it like that first. What it will do is it'll take the first element of the first list. It'll take the first element of the second list, and if there's a third list and a fourth list, it'll take the first element of those as well, and then combine that into a tuple. And then that will be that result tuple will be the first element of a list. All right, now let's make the second element of the list. The second element of the list would then be the second element of the first list, second list, if there's a third list, fourth list. That will be stored in a tuple, and that will be the second element. So the example that I give here is a little bit more simple, and it'll probably make it a little bit more easier to understand. We have names and we have majors within a list. And so names is Alice, Bob, and Carl. Majors is CS, math, and physics. And so with the zip object, what I'm doing here is I'm creating a tuple of Alice and CS, Bob and math, and Carl and physics. What I'm doing here is with these two lists, with these two iterable objects, these iterators, I'm getting the first element of the first iterator, the first element of the second iterator, and then I'm putting that within a tuple, Alice and CS. Then with the second element of the output, I'm taking the second element of the first list, second element of the second list, and then I'm putting that in another tuple as well. In this case, it'll be Bob and math. I'll do Carl and physics because those are the third elements of all those lists. Now, it's not exclusive to just two lists. You can use tuples, you can use all the other iterable objects that you can use. And you're not confined to just using two. You can use three in this case as well, and it will do the same thing. But in this case, what would be the length of the tuple, each tuple? If you're using three iterator objects, let's say names, majors, and GPA, each tuple will be a length of 3. Okay, so keep that in mind. So you can use more than one iterable object. Now let's say if there was another dude on that name. But majors were just 3 elements. So let's say it's Alice, Bob, Carl, and what's another like really white name? Billy. Yeah, Billy. Yeah, so let's say Billy is there as well. In that case, this output will just take the first 3 elements, and Billy won't even be in the result output. It'll just keep with the different lengths, it'll just adopt the length of the fewest elements list. So names would have a length of 4, right? Because we added Billy, but majors has a length of 3. We don't really have a major for Billy, and so when we zip that, Billy won't be included. Okay, so Billy will be left out. Okay, so that is the Python zip function. Let's see if we can do an example here real quick. Okay, so and a lot of these examples, by the way, you can do them in a different way. You can do them in probably in a much more easier way, in a different way that doesn't involve the zip function. But I'm only including the zip function so you guys know how to actually use it. So keep that in mind, that let's say if it says not use it, there's another probably easier way of answering this problem. But I'm only including zip so that you guys understand how to actually use the zip object. So in this case here, it says given a list of numbers, use zip to add the corresponding elements of each list and return the result as a list. And so what is it telling us? Well, so it's first telling me to actually erase the elements here on this board so that we actually have room to write the answer. All right. So it says here given two lists of numbers. So I'm going to do numbers 1 and numbers 2 list. So we'll do numbers 1. This is an undercase, and we'll do 1, 2, 3, 4, 5. And then we'll do numbers underscore 2. And that'll be 6, 7, 8, 9, 10. Right? That's awesome. Now what is it asking us to do? So it says they're given the list of 2 numbers. So we have a list of 2 numbers. Use the zip function to add the corresponding elements of each list and return the result as a list. So what I'm going to do is I'm going to use the zip function, and I'm going to use the list comprehension feature as well, because I don't want to put too many lines of code. We're just going to keep it simple and combine the 2. That way we have a result array done in one list. Okay. And so we'll use the list comprehension. So we'll store that list first of all in a result array. So we'll do result array. And then when we start a list comprehension, well, if you start any list, to be honest, you're going to need square brackets. And then from there, what are we adding? Well, we don't know what we're adding just yet, but let's see. If we're zipping something together, well, what is it asking us? It's asking us to add the corresponding elements of each list. So if you look here on this chalkboard, basically what I'm going to do is I'm going to try adding 1 and 6, 2 and 7, 3 and 8, 4 and 9, and 5 and 10, because I want to add the first element of the first list, the first element of the second list, and then, keep on going. So like the second element of the first list and the second element of the second list will be added. Okay. So we don't know what we're going to be adding to the list just yet, but we are going to use the zip function. And what does the zip function tells us? Well, what the zip function will do in these case of iterables is it'll create an object. Let's say if we apply the zip function with this, let's say if we say here, zip numbers 1 and numbers 2. Basically, what it will do, and if we, store that as a list as well, what it'll do is it'll basically create a list of tuples where it's going to be 1, 6, 2, 7, 3, 8. That's not an 8, that's a 6. But yeah, I just fixed that. 4 and 9, and then 5 and 10. Okay, so if we use the zip function on these 2 lists, assuming that these 2 lists are the only parameters, it'll result with this type of list. Now, what's awesome is that if we know that this is the thing that we're going to be iterating through, we can, and we have to find the sum of 1 and 6, 2 and 7. What we can do is we can almost, in a weird way, index the first element of the first tuple, index the second element of the first tuple, and then we can do that on every single list. So what I'm saying here is that we can iterate and say here for X and Y in zip numbers 1 and numbers 2. Okay. What was that there? Okay. So for X, Y in zip numbers 1, numbers 2, so it'll basically iterate this for loop that I just created for X, Y in zip. It'll have an X value and a Y value. And so for the first iteration, this will be the X value, this will be the Y value. So that's the first iteration. This will be the second iteration. This will be the third iteration. This will be the fourth iteration. And this will be the fifth iteration. And it'll take these values at each iteration. Okay, so at the first iteration, this will be the X value, this will be the Y value. At the second iteration, this will be the X value, this will be the Y value. At the third iteration, this will be the X value, this will be the Y value. At the fourth iteration, this will be the X and Y value, this will be the X and Y value, and in the fifth iteration, this will be the X and Y value. Okay? That's awesome. And so now we have an X and Y value that we're getting at each iteration. So we're getting 1 and 6, 2 and 7, 3 and 8, 4 and 9, and 5 and 10, respectively with X and Y. And we want the sum of that. And so for every iteration, what we're effectively want to do is we want to add X plus Y and then store that within the list. And so this will be our answer. Okay. And then when we, let's say when we print out the result array, it should output a list with 7, 9, 11, 13, and 15. Okay, so that's how you use the zip function in a problem like this. And I also include list comprehensions because, you know, can't forget our list comprehensions. Okay. So yeah, that's the answer for y'all there as well. There's another example problem for you guys to use if you guys want to do that in your free time. Let's go to file IO. Okay, we got like 30 minutes, so we'll cover file IO. Yeah, let's go file IO. Okay, so with file IO, there's going to be a bunch of methods to come across. Now, these are going to be super important because in your future assignments and projects, you'll be given most likely a CSV file or a TXT file with separated with commas. And so your goal is to use that CSV file and extract data from it. But how can we extract data from it if we don't know how to import that file into a Jupyter notebook, for example, and then separate the different elements, get the different elements, even alter it? Because oftentimes when we get a CSV file, the CSV file will be kind of, it'll be kind of ass, not gonna lie. And so what we're gonna have to do with that CSV file is to pre-process the data. Pre-process meaning that if there's different gaps in the data, if there's a missing element, even if let's say a header is not there, we have to pre-process the data. And so to actually pre-process the data, we have to be able to read the file, we have to be able to write on that file. So we'll be discovering using the different methods or finding or learning about the different methods that you would use to apply that. First one's probably the most important because you wouldn't be able to use it. You wouldn't be able to use the file without actually opening the file within the notebook. And so the open and then in the parameters path function is used in Python to open a file at the specified path and returns a file object. This file object can be used to perform various operations on the file. So as you can see here, it says f is equal to open in parentheses sample.txt, and then in another parameter it's r. Okay, we'll cover the r in just a second. But keep in mind that oftentimes in these examples with files, we'll keep file either as the file name or we'll keep it as f. Keeping it as f makes it very simple because now you're accessing the file just by with f. And so that helps us remember that, hey, the file is in the f variable. So we'll often use f as the file variable to access the actual file that we want. Open will actually open the file, that's the method name. Sample.txt is the file that we want to open, and this can be different files. It doesn't have to be just a txt file, it could be a CSV file. And there's different ways that you can use that. And so .txt, sample.txt is just an example. The R simply means read. We'll cover a little bit why we have an R there, because it might not always be an R, for example. So f equals open sample.txt. R is the syntax that we use to actually open a file. And now with this sort of function, we now have a variable that represents a file that we can access, that we can, well, I don't want to say write just yet, but that we can read. That R represents read. Okay, so now let's actually read the file. Okay, so read is not the only function when it comes to reading, but it's one of them. F.read. So f, as you guys know, is what the file variable is. So when we use f in the future slides, just know that that's the file, and you cannot do those steps without opening it. Even if you guys notice here with this code, I started off with opening the file. So f is equal to sample.txt with r there. So the read function, what is the read function? Well, the read function is basically just a method of a file object in Python that reads the entire content of the file and returns it as a string. And so basically with this read function, all it's doing is getting the contents of the file that you're given, that you open, you have to previously open the file, and then once you do that, it'll store all the contents. Let's say in this txt file, it says, hello, how are you? It'll store hello, how are you as a string in file contents. And then when you print that out, you can print that out, and then it's also important to close it. We'll cover what closing means, but basically closing just prevents things to happen with your file, and uses less resources. And that's going to be especially important with bigger files. With bigger files, you're going to have to close it because it could be using a lot of resources in the background. But that's a thing for another day. But my point is that read function is really cool function to store all the elements of the file that you're opening into a variable. What does the R mean? The R just simply means read, okay? We'll cover this a little bit why it's there in a second, actually. I have a slide dedicated to just that, so just keep that in mind. But just know that the R simply means that we're in read mode, meaning that we're not going to be changing the elements within the TXT file, the R, or the CSV file. We're not changing, we're just checking it out, we glancing at it. I'm not going to be altering that stuff. We're just going to be looking at it. Read lines is basically just a method of a file object in Python that reads all the lines of the file and returns them as a list of strings, where each string represents a line in the file. And so when you guys open, let's say, a TXT file, not everything is on the same line. There's multiple lines in the CSV, or actually TXT file in this case. And so with the TXT file, let's say you don't want to store all the contents of that TXT file as one string. That would be crazy to have all of them as one string. And so the read lines method is a lot more better in that the read lines method stores each of those lines as its own string. And then once it gets all the lines as its own string, it returns a list as a string. Okay, so in this case here, we open sample.txt r lines equals read lines. And so if we want to print the lines within this case, you can iterate through that. Read lines will return a list. What is a list? It's an iterator, something that you can iterate through. Iterators can go through a for loop. You can iterate through with it with a for loop. And so in this for loop, after I apply the read line methods and store all the lines as a list in the lines variable, I print out each line, and that's how I print out the contents of that file. And then again, of course, we close it. Right? Close method. So the close method, I think I covered this a little bit already, and I think you guys kind of got the gist of it, but just to formally teach it, it's basically the method of a file object in Python that closes the file. Now it's important to close the file, so because once you finish working on it, because there's going to be resources that are used when that file is open, and if you're no longer using that file anymore, just close it because you no longer need to use it anymore. So why waste resources? I know with the assignment that you might have here, it might seem chill to just leave it as open, and it will often work. It's not going to cause a problem. But once you're in the industry and you're using a lot more data, a lot more CSV files that have millions of data entry points or lots of data, it's going to be important to close it because you're just using or wasting unnecessary resources. So the close method would let you close the file once you're done using it. Okay, now there is another way to actually read the file. This is often the example that you're going to probably see the most, and that is with width. Reading a file using width. So why would we use width to open a file? Well, in Python, you probably have noticed that alternative ways to do something often means that you're avoiding an error. You're avoiding something like that you might come across. So if you're using other reading methods, it would work. And assuming that there's no errors, it will work. But with the width function, let's say if an error does occur, the width function will tackle that. So it automatically takes care of opening and closing the file. So opening and closing the file is awesome. It's done with it. You don't have to, with the width function, you're automatically assuming that you're opening the function, but you don't have to include f.close within it. You don't have to include f.close within it. And that's pretty cool. Okay, so once you're done with the width, and it almost kind of looks like a method in its syntax. I don't want you guys to think of it as a method, but you can kind of think of it as like that because it'll say with and then with a colon, and then the lines within that with thing will be indented. And so once you're done with the file, you will just, undo the tab. So in this case here, if you look with open sample.txt R as F, you're basically opening this sample.txt file, you're naming it F, that's file name, and then you read the contents. But then once you're done with the contents, and you notice here with all these lines, it's indented. So once you're done with, with the file, just like no longer indented. Think of it like, with the if statement. If you don't want to include it within the if statement, what do? You just don't indent it anymore, and that's done. That's done with the if statement. So same thing with here, with open. Yeah. Okay, so there's going to be an example, I think. I don't know if it's the next one. All right, so it says here to, let me get my notes here. Yeah, so it says here, write a program that opens a file named numbers.txt and then prints out the sum of all the numbers in the file. The numbers in the file are separated by new line characters. What does new line character mean? It just simply means there's like a slash and then n, and then it just creates a new line. And so we know that with every number in this txt file, it'll be on a new line. So in this file here, we have 1, 2, 3, 4, and the output should be 10. Why should it be 10? Well, 1 plus 2 plus 3 plus 4 is equal to 10. So we just want to find the sum of all these values. Okay. And so we're basically asked to write a program to take the input of this as a txt file, so numbers.txt, and then output it as a sum. And so let's do that. Let me erase this, and then we'll do this problem. What are we not doing, by the way, in this problem? I know that question might be a little bit vague, but I want to see if you guys know. What are we not doing in this? Okay, let me rephrase it. What are we not doing to this file? Yeah, we're not changing anything. So we're not changing anything to the file. I know the question was kind of vague, but I just wanted to let you guys know, like, we're not doing anything with the file. So when we use the the with thing, when we're reading this file, let me put it like that, we're not going to be in writing mode. We're not going to be changing it. We're just going to stay in reading mode. We're going to just extract the data, and then we're going to use it for our own purposes, but we're not actually changing this file. We're just outputting number 10, the sum of the values. Okay. So let's do that. Okay, so what is the name of this document? It's numbers.txt. So it's a txt file. We're in read mode. So let's use the with thing. So we'll do with open. What are we opening? We're opening numbers.txt. What mode are we in? We are in reading mode, and so we'll leave that as R. And then we'll say the name of the file as F. Okay, and then we'll do colon there. Okay, and so we'll leave it as that. And now what do we want to do? What function do we know that we learned previously extracts the values that we have here? Oh, not here, there, my bad, as a list of numbers. So if I, let's say, use the read function, what would it do? It'll store it as a string. But what would that string be if I use the read function? So the read function, if I do f.read, what would it return? Remember that the read function returns a string. So what is that string? Yes, it's just going to be 1, 2, 3, 4. Now, we can use this, but is it ideal? No, right? Now, if we were to use this, what we would do is we would extract these values, each string, and then we'll convert each of those characters into an integer, and then from those integers, we add them together. But there's actually a function that we already do know that that rather than creating a string, it creates a list of strings. You guys recall what that was? Yes, it is read lines. And so we'll be using read lines as our way of getting the numbers. And so what does it return? Read lines. What does read lines return? Yeah, a list of what? Try again. Yes, yes, a list of strings. So what it's going to do is going to return a list of strings. And so let's do that. We'll do numbers is equal to f dot read lines. Okay, so now we have the numbers, but they're stored as strings. So within numbers, it's stored like this. So it'll be 1, 2, 3, and 4. Now the thing is that if I add these numbers together, it'll be 1, 2, and 3, and 4 because it's treating it as a string. It's treating it as characters. And so when it treats it as characters, that is not what we want. We want the sum of those values. So you guys, in this case, would have to use some type of casting method. And so casting does is it converts these values into an integer. So we would do, for example, int 1, and that will just simply be equal to 1. But the difference is that you can actually do arithmetic operations with it. Awesome. And so let's do that. Let's first create a list of numbers. We can store that within numbers, but we can also store that in a new array. In this case, we'll just store it within the same array or the same list. Okay. And so what I'm going to do is I'm going to create a list comprehension that converts all these values into integers. Okay. So what I'm doing is that I am iterating through the numbers thing here, the numbers, the string of numbers, the list of number strings, and then I'm just converting them into integers since we can assume that they're integers. I don't know if the problem says that. Yeah, numbers, but we'll keep it as integers for now. Okay, and then we can do that the result is equal to, I believe it should be sum. Let me just double check on that actually, just so that I'm not caught lacking. Yeah, I'm not caught lacking. So the result will be equal to some numbers. And so when you print out the result, it'll output 10. Any questions with this so far?
And so for the second, just strictly for the second line, if you want to typecast it to integer, we can just put into parentheses and then within that f dot read lines.
F dot read lines. The issue with that is that it'll, if you do, let's say if you're saying like int f dot read lines, right?
Yeah.
The only issue with that is that it will store 1,234 as an integer.
Oh, I see.
Yeah.
Okay.
Wait. Actually, no, I don't know what it would do actually, now that I think about it, because each of those values is stored in a list, right? Yeah, so.
Would it become just a list of integers?
Actually, I've never put a list within the integer. I never casted it like that before. But if that's the case, actually go ahead and try that. That actually might be a more efficient way. So assuming that you can put a list of string that represent a number within like the in parentheses, try that and see if it returns it. But in this case, what I'm doing is I'm just pretty much doing like the same thing where I do like list comprehension and then I'm converting each element individually into an integer and then storing it within the same list. But if that works, go ahead. That actually would be awesome. I was actually, before when I was saying it didn't work, I was actually thinking about it in the context of just read, but read lines might be a different story. All right, so let me see how much time we got. We got only 2 minutes. So let me just finish up with collections actually. Wait, let me okay, so let me just rush through this remaining part. Okay, so there are a bunch of reading functions. So with read n, you're basically you can take an input of an n value. So it reads n characters. So in the case, let's say if we open a file.txt file, a file.txt file, and we read it, if we say, hey, data is equal to f.read 5, what it will do is it will read the first 5 characters, and they'll put the pointer after the 5th letter or the 5th character. And so let's say if our data was hello, how are you? And we're like f.read f, it's going to print out the first 5 characters. And in this case, it will output hello. Okay. And the print pointer at which it's reading up to will be after the 5th character. So it will be after O, since O has been already read, if that makes sense. Okay, now tell is a little bit more different. Tell is going to tell us the current pointer that we're at. And so we'll use the previous example exactly as I said. So we're opening a new file. We're reading up to 5 characters. So hello, how are you? We're only reading up to hello. And so we're now checking to see where our pointer within the read function is, or where our pointer is with this sort of function. And so f.tell will tell us, okay, we are at this position right now, and it tells us that the current position is 5 because we've told it to read up to 5. All right, so that should be the tell function. The seek function is a little bit more different. So in this case here, it's basically you take in a, actually, let me go back so I can show you. Okay, so seek function is a little bit more different. Rather than reading all different values and then printing it out, what it will do is it will actually just go to the byte end. So if you tell it to go to byte 10, it'll go to byte 10. And so you have this example here where we read up to 5 elements, and then it tells us, okay, that we're up to this point, we're at current position 5. But then let's say if we want to go from the 5th byte to the 10th byte. And so we tell it, okay, seek the 10th byte, and then it that pointer that we're looking at, the pointer that we're using to read it, think of it as a book. So let's say if you're reading a book and you're going by, let's say 1, 2, 3. Now it's a bit like, you know, very basic the way I'm explaining it, but think of it as we're reading a book with our pointer finger and we're going like this, and we're telling it to stop right here. So when I say seek, let's say if I want to say seek, I don't know, the 6th byte, I'll go 1, 2, 3, 4, 5, 6, and then I'll do, my pointer is going to be there. Okay, so when I say seek, think of it as me moving my pointer finger while I'm reading to that point. Okay, but if I actually want to read that rather than, you know, just skipping to that, I'll use the read function, and then the tell function will tell us where my pointer finger is. So that's just a bit of an abstraction that you can use to remember what these different methods are. Okay, and so I have a bunch of examples here. There's a bunch of file modes that you can use. So you were asking about what the R meant. Well, the R can be actually changed. So one is, well, R, and that will just tell us to be in a read mode. There's also the write mode. In that case, we'll be using W. And then we can append, and if you want to possibly create something, we'll use an A. Okay, so those are the different values that could store within those quotation marks over there. And so we'll mainly be using R because we're going to be using that to extrapolate data and then, like, you know, run some tests. But in the case that we want to pre-process data within that, we'll use W. And if we want to just simply add data, we'll just keep it as A. Okay. By the way, since I'm rushing, because I want you guys to get here out on time, all the files are on Canvas. Okay. So if we want to write to a file, we could say with open and then the output.txt file, or we can create a new file, and then we're in write mode. So we put those quotation marks as W. So now we're in write mode. We have the file name as F. And so we're like f.write, hi there. And then you can also write f.write lines, and that will create multiple lines. So if you're using just the write function, it'll do it all in like this one line. Whereas f.write lines, you can put multiple parameters, and that will put it listed. It will put it in the txt file as multiple lines. All right, so this is another example that you guys can try in your free time. All right, so collections is the last thing I'll do. And collections is the easiest one because it's just a bunch of classes within a module called collections. So collections is simply a module that you can use in Python that provides alternative data structures to the built-in data structure in Python. So you're already probably aware of the multiple data structures. We did a whole lesson on just data structures. Well, what's cool about collections is that it'll introduce you to alternative data structures that you can use that, like, you know, fix a bunch of the problems that you might have, and it'll make a lot of the things a little bit more easier. Okay, so in these alternative data structures, they're oftentimes more efficient or easier to use than their built-in counterparts. And all they're doing there is simply making the code, you know, much more simpler and more readable. But on top of that, it comes with, like, you know, basic fundamentals that allow you to just do things right from the get-go. And I think a good example of that would be default dictionary. So default dictionary is basically a subclass of the built-in dictionary class. And this differs from a regular dictionary because it provides a default value for every single key. Let's say if you want to access an element that isn't there. When you access an element that isn't there, what's going to happen? It's going to say no value, or it's going to say nothing. Nothing is there that can be accessed. But in the case of default dictionary, what it does is that if you do access an element that you haven't previously assigned a value to, there's going to be a default value there for you. So in the case of this code right here, we're creating a dictionary that includes all the word counts, or like, the how many values of a number that can occur. And so when we create a default dictionary and we say that we want a dictionary of integers, what happens is that with every key, there's going to be a default value of 0. So if we access something within it, the default value is going to be 0. And so that allows us to that allows us to skip the step of creating a key for every single one and just going in. Whenever we find a new thing, we can just increment that value by 1. So with this method, what I'm trying to do is I'm trying to find the frequency of the word. Normally what I do is if I would check to see if that value exists in the dictionary, and if it doesn't exist in the dictionary, create that key and then add 1 to it. But if it does already exist, we'll access it and increment it by 1. What the default dictionary allows us to do is minimize that to 1 line, and we just increment it straight from the get-go. And as you can see, we don't have to create this sort of if and else statement there. We're already incrementing by 1 if we find the value there. Okay, so words.count world, I never created a world key. If you guys notice in this code, I never created a world key. However, it doesn't print out an error. It doesn't print out saying, oh, this doesn't exist. It outputs 0 because 0 is the default value for this key. Okay, so that's an example of default dictionary, and this is really cool because it makes the job of finding default values, and you don't have to create like an if and else statement when adding values to a dictionary if you're doing it for the sake of frequency. All right, so this is a example problem, and then this is the last one, counter. So counter is another thing within what's the name of the module? Collections. There you go. So counter is another thing within collections, and you can see what the code is doing here. Basically, what I'm trying to use the counter for is to count the frequency of words in a list. And so I have this sort of list of words: hello world, hello Python, hello. Hello comes up what? 3 times, world comes up once, and Python comes up at once. And so rather than creating a method or creating a whole spiel of if and else statements to see the frequency of the words, what I'm doing is I'm doing it right with 1 line. Word counts. Word counts is where we're going to be storing the frequency of all these words. And then I use a counter, the counter class, and I put the list of words as my arguments or my parameters. And so what this does is that for every word, it creates a frequency. And so with counter, it's saying, okay, hello comes up 1, 2, 3. So it will be hello : 3. With word, it's only 1. With Python, there's only 1. And so it creates sort of dictionary. And within that dictionary, it'll have the key with the word and then the frequency as the value. And then when we iterate through that with this for loop over here, for word count in word counts.items, the dictionary, so we can use the items method to find all the items. We can then use this formatted string to say, hey, print out the word, print out the frequency, and then the output should be hello 3, world 1, and Python 1. And so rather than creating a bunch of if statements, else statements, a new data structure altogether, we're using simply 1 line of code to find the frequency of we're using 1 line of code to find the frequency of the words in the list, which is super cool and makes the jobs a lot more simpler. And so that's why collections is super cool, because it has built-in classes, has built-in data structures that makes the job of the other data structures a lot more easier. It builds upon the data structures that we've already learned and does it in a much more simpler way. And so this minimizes the code, makes it more efficient, makes it more concise, makes it more readable. So if another person were to go and check out your code, hey, they know what the heck is going on. They don't see a bunch of if statements. And these are the other two. These are not the only classes within it, but these are other other popular classes within the collections module that are often used. So name tuple names a tuple, and then dequeue, you can search that up and see the practical applications. I don't think Ames covered it, so I'm not going to cover it, but those are other collections that you can use for your assignments potentially. And that wraps up recitation. All right, so I'm gonna what is it? What was it? 1 hour? I'm looking at it right now. So yeah, luckily we got everything done since this was a meaty section. But next week we'll be doing NumPy. So NumPy is pretty cool. You probably heard of NumPy. Pretty popular in data science, and you guys learned it already today anyway. So we'll do a whole recitation on NumPy next week. So I'll see you guys then. I hope you guys enjoy the rest of your week. No problem.